Well, it's really nice to be here. This is my first time at St. Thomas University. I like talking with college students because I'm an old fart, and what's coming climate-wise to this world, I'm not going to get to see most of, even though I'm the one who caused the problem. My generation, my parents' generation, my grandfather was an industrialist. He put the stuff up in the air, carbon dioxide. He didn't know what he was doing. But people have known about this for an awful long time. All right, so I go out and I try to talk to young people. I talk to Rotary clubs, Chamber of Commerces, and political groups, but I concentrate on universities and high schools because you are the people who are going to be saddled with this horrible thing that's coming to this earth because of the way we burn fossil fuels and the way we put carbon dioxide up into the atmosphere. Bottom line is, you keep putting carbon dioxide up, it's going to get hotter, and when it gets hotter, it changes the whole environment of the earth, and it does it radically, and it does it very quickly. All right, so I'm out here trying to do my part to make up for all the bad things that I did in my life, okay, to help cause this problem. And like I said, you guys may have the chance to fix it. I'm going to go through this. I appreciate it. If we don't do any questions, let me run through it, and then just jot down what you see. Now, I brought a very comprehensive slide deck here. I have many, many shows. I probably have 125 different slide presentations, depending upon the groups that I'm going to talk to. This one was comprehensive because I have a long time to do this. So when you get out of here, you really are going to have a climate education, a global warming education. I'm going to go through it all for you. Water and ice is what I call this. And here we are. And I do appreciate, again, having me here. So let's get into it. You know, this is kind of spiritual right here, and it's good being in St. Thomas University. You know, I look at the hand, the painting back up on the wall there of, you know, Moses touching Adam's finger right there. With God touching Moses' finger, I think that's what it was, God touching Moses' finger. All right, this is the world breathing. You know, you don't have to be a real religious person to realize that this earth is alive. It breathes just like we do. We breathe, we take a breath in about every second, we breathe in oxygen, and we put carbon dioxide back out. The earth, and this is over a 7 or 8 year period between summer and winter, you can see winter coming down with the white, summer going back up with the green, breathes the same way that we do. If you look at it over a billion-year period, it's breathing about once a second too, like this is showing you. And what it's doing is taking in carbon dioxide. Photosynthesis with the plants splits the carbon dioxide, CO2, one carbon, two oxygen atoms together to make that molecule. It holds the carbon dioxide through photosynthesis inside the plant. That carbon is the power, and it puts the oxygen, two oxygen atoms, back out. So it's making our oxygen, and the earth breathes just like we do. Unfortunately, we've kind of upset the balance. Now I can tell you this, the earth will go on breathing long after we're gone, because we're only 500 million years into the billion-year epoch of the Earth's total life. Only a billion years of this epoch will be able to have life on this planet. The sun's going to get too hot, it's going to shrink and grow, the Earth's going to change where it won't support life anymore. That's just the general way that the planet goes. Formed 4 billion years ago, and it goes another 3 billion or so, and our billion in the middle right here is perfect. The sun's just the right temperature, we're just the right distance away, and there's a billion-year swing there. We're 500 million years into it. So we got another 500 years to go, so I'm sure no matter what we do, the Earth is going to come back, clean itself out, regenerate itself over the next million or 2 years, and start again. Evolution goes back on, and everything starts again. So this one slide is going to make you a global warming expert. Because this one slide, and my whole slide deck, tells you why and how this is happening. And it's a very simple thing. If you look at the green line right here, that's how much carbon dioxide is in the atmosphere. The way we know this, Vostok was a Russian research base in Antarctica, and 2.5 miles below it was a liquid lake, and they wanted to see if anything was living in that lake, still liquid under the ice, and they drilled down, taking ice cores out. So as they took the ice cores out, they could look at the stratification of each year's snowfall, just like we do tree rings, okay? We can tell how old the tree is. So they could go back and look. Now, in those stratifications of the snow, in these ice cores, little teeny bubbles of air were trapped. And scientists are able to go in and look at the chemical makeup, composition of what's in those little bubbles. So they can figure out how much carbon dioxide, as they went through these ice cores, and corresponded to the years. And that's why you see this chart. And what's interesting about the chart is, you'll see that the average for the past 400,000 years, and actually now, they got to the lake, goes to 800,000 years here, but the same average runs right through it. So for the past 800,000 years, really, we've been about 230 parts per million of carbon dioxide in the atmosphere. That's not a lot when you consider that when there's less, down here you get ice ages. So these are the ice ages. All right, so this was only, what, 170 parts per million? Got cold enough to put 2 miles plus of ice on top of North America and Europe. All right, and to melt that ice off, it only took about 250, 260 parts per million to melt all that ice off and get us back to where we are now. The problem with what's going on right now is that this is where we are now, 404 parts, and actually I didn't update it, I looked at it yesterday, it's 406.54 parts. So it's going up and up and up. Parts per million of carbon dioxide in the atmosphere. We haven't been there for 15 million years. Now we were there, the Earth's atmosphere has more CO2 in it, it gets hotter and colder. It's normal, the CO2 comes from volcanoes, all kinds of other things. But we made this one. This one we made. Mankind did, burning fossil fuels. So 15 million years ago, the oceans were 100 feet higher, and the average temperature was 15 degrees Fahrenheit higher. All right? The Earth was a whole different place. 100 feet higher means most of Florida would be underwater, and was at that time. All right? And the reason that it gets higher when it gets hotter is that water expands when you heat it. It's a simple scientific fact. You don't have to be a scientist to understand that. All right? And it does get hotter. So what I can tell you is that this red line right here follows exactly, that's the heat, how hot it was, follows exactly how much carbon dioxide was in the atmosphere. All right? Now, you see where we are right now. You're expecting that this is going to very soon follow it, and it is. You know, in Miami this summer, we rarely got below 90 degrees unless it was a rainy day. But every day was really 92, 93, 94, 95. And our average temperature, instead of being 82 degrees average, high to low in the day, was like 87 degrees. And this has been going on and on. When I grew up in Miami, our highest temperatures were like 88 degrees. That was a hot summer day, 88 degrees. We don't get that anymore. That's a winter day here starting. You know, you think, what was the last time we put a sweater on here last year? I think it was January 3rd or 4th. We got cold enough to actually wear a sweater, and then that went away, and that was our winter, okay? So it's amazing. Now, here for us in South Florida is the really heavy-duty kicker. That blue line is sea level. Sea level follows the heat. Sea level follows ice melt. If it gets hotter, ice is going to melt. If it gets hotter, water expands. So you can see it goes up and down exactly the same way. If we don't take any action to curtail how much carbon dioxide we're putting in the atmosphere, that means going to renewables, getting rid of burning fossil fuel. You can use oil and stuff to do other things. You make chemicals out of it, you make plastics, other things that we need it for, rather than just burning it up to go to work in the morning and putting all that carbon dioxide in the air. Okay. If we don't stop doing that, we're going to get to 1,000 parts per million of CO2 in the atmosphere, all right, by 2100. Now, if where we are right now, we haven't been there for 15 million years, and it was 15 degrees hotter, and the oceans were 100 feet higher, what's going to happen there? Now we're only talking 80 years from now, guys. We're not talking millenniums. We're not talking millions of years. We're only talking 80 years, 1,000 parts per million. The Earth will respond to that right away, as we are right now. So that gives you a pretty good idea of what's going to happen here. So you're now experts, right? Everyone got that? That was pretty simple, wasn't it? You know, if you add 2 to 2, you're going to get 4. And that's the way the science works on this, and it's well proven. I don't know how people say it's a hoax, because you can look at actual gauges and things, not people, gauges that keep showing it working like that. Now, I have friends who say, it's underwater volcanoes blowing up. They're putting the carbon dioxide up. Oh no, it's the forest fires that are putting the carbon dioxide up there. We have forest fires all over the place. It's other things. It's cow poop that's putting we have lots of cows that's putting the carbon dioxide up there. Okay? Not true. It is fossil fuels that has got us to this point. Then you get forest fires and things like that. Okay? But that's what happens. You know, they also say, how in the world, when you go walk out here and look up there, and it's a big blue sky, how in the world can we fill up this atmosphere with so much carbon dioxide, all right, that we can change the whole world, because it's so giant. The reality of the situation is that if you go 6 miles up, top of Mount Everest, you can't live there. You can't breathe there. You need a bottom. That's why planes are pressurized. All right? So our atmosphere, our livable atmosphere, is very thin. Take a beach ball about this big, put a coat of varnish on it, and that would be that 6 mile thick atmosphere. Only that thick. And we put 40 billion, 39, 36, 42, depending on the year, billion tons of carbon dioxide into this little thin atmosphere every year. And that, you know, okay, 1 year, great. Problem is that the half-life of carbon dioxide is 100 years. So that means when I drove here from Miami Beach, the carbon dioxide that came out of my tailpipe goes into the atmosphere, and it will be there for 100 years, heating up the planet. Then, half-life, 50% of it is left for another 100 years, heating up the planet. And then 25% is left. Do the math. You do 40 million tons, 40 billion tons a year, and it takes 100, 200, 300, 400, 500, 600 years for that to stop affecting our planet. You can't get out of it. The only way to get out of it is to stop burning it, period. Done. And then try to figure out a way, engineer a way, to start sucking carbon dioxide out of the atmosphere. And that we probably could do. But you got to stop burning it first. Starts in 1880 to 1884. These are increments of 5 years. When you see red, yellow is getting hotter, okay? When you see red, I don't know why this hasn't started. Slide should start. Let's go back. This is a brand new slide I did yesterday. Now let's see if we can start it again. I hate malfunctions. What happens here is that if it won't run, the very top, the northern part of the world gets hotter and hotter and hotter until it's bright orange. All right, when this says 2015. So down here in Antarctica, in this area right here, the Ross Ice Shelf, it gets very hot there too. So it's just at the poles that this is happening, but more importantly, it's in the northern latitudes that it's happening. And what we've got, here's where I'm talking about down here. This is the size of Rhode Island. Now this calved off 2014, I think it was, but just this past spring, we had an iceberg break off that shelf that is the size of Delaware. One iceberg. All right, that shelf holds all the ice that's on Antarctica, holds it up on the land, so it doesn't slide in. That floating ice, that doesn't raise sea level, but if the ice that's up on the land slides in, sea level goes up. And I have another slide about that later. The reason it's getting hotter in the northern hemisphere is that the jet stream has slowed down in the past 25 years. Now, would you believe that mankind could slow down this massive 200-mile-an-hour stream of air that goes around the Earth from west to east? We can, and here's how it happens, okay? That's a pretty neat illustration. What made the jet stream run was hot air down here by the equators, and the cold air up there, and the jet stream acted as a fence, a wall, and it would not let the hot air get up into the northern latitudes, and it kept them separated. So then, a few years ago, probably 15 years ago, we started seeing anomalies in the wintertime when Arctic air came down, and for instance, in Atlanta it would be 7 degrees, and in Anchorage it would be 57 degrees in the middle of the winter. That means we started changing where the hot air was because the jet stream wall wasn't there to hold the cold air back or to hold the hot air from going up. And why would the hot air go up? Hot air is thicker, expanded air is thicker, cold air is denser, and the Earth actually is curved, and without that wall there, it runs downhill, right over where the wall used to be, which was the jet stream, all right, and puts the hot air up into the Earth. Now, who would have thought that? This is all new stuff. This is within the past 10 years that scientists have gone, oh my goodness, look at this. Well, it's radically changed our weather. We have a hurricane right now in the middle of the Atlantic that's going on 3 weeks, Hurricane Lee. It's a Category 2 today. It has stayed within the same little 200-mile area for almost 3 weeks. Normally, the jet stream would grab that sucker and take it out and send it to Europe. All right? Hadn't done it. It's still sitting there. Eventually, it might. We have our first cold front coming down this year a little earlier than normal. Normally, it's October the 15th for South Florida. We're getting into the beginning of October. And this weekend, we're going to have our first front. It's going to push all the way through. But it's going to start another tropical storm right here over us that's supposed to move north. So get ready for that this weekend. All right, it's been quite a season, I've got to tell you that. All right, so that is what's happened. The jet stream slowed down, and that's why it's getting so much hotter up in the northern latitudes, and that's what melts your glaciers, and that's what melts your ice sheets. Okay, and down here I'm going to talk about the Antarctic in another. Now here, this is Hermine. This was 2 years ago. It sat off of New Jersey and New York. It was a hurricane, then turned into a tropical storm. For 7 days, sitting in the exact same spot because there was no jet stream to pick it up and take it out. All right? We never saw that happen before until again this summer when we've had some hurricanes just sit there. Jose, just out, back, around, in, back, around. All right, I do remember it was Donna or one of those when I was a kid. It went out into the middle of the Atlantic near Bermuda, turned around, came back and whacked us. Whacked us the first time going one way, turned around, came back, hit us again. All right, but that's the only one I remember that. All right, now here's the ice I was talking about in Greenland. The white is really thick ice, 9 years plus, some of it is 10, 15 feet thick. Most of the Arctic was that ice all the time until we started these anomalies where it got really hot and it started to melt. The blue ice that you see there is new ice from the winter, a foot, 2 feet, 3 feet thick. We now have storms because the wind patterns have changed, coming through the Bering Sea and up into there, pushing ice. The storms run from the west to the east. They're pushing all this ice out the Fram Strait, breaking it up, and pushing it out because it's not real thick ice. And now we end up not only being able to drive a ship across here, but with very little of the old ice left and a lot of new ice. Okay? Scientists are saying now, 2040, 2050, there won't be any ice there. And the problem with this also is when water is exposed, it's dark, so it sucks in sunlight and heats up even more. So it exacerbates the whole situation. I love the way these slides change. That's a pretty good one, right? All right. We're going to be looking at Greenland, and where you see red, that's where it's melting really fast right now. And you'd expect that around the edges, not in the middle. As a matter of fact, the middle is building up a little bit when it gets snowed on. But here's what's going on. It starts to melt on the surface and forms little streams. there's no place for it to go because it's got 2 miles of ice below it, okay? These little black specks you see all in here, that's carbon. That's from power plants burning coal. China, Midwest, US, turns into lakes. There's still no place for it to go. By the way, that carbon makes the ice pull in heat quicker because it's dark. So it goes down, carves out a hole called a moulin, runs all the way down to the bottom of the ice. Then it lubricates the bottom of the ice, so it's sitting on water floating, ice floats. All right, and these ice sheets start sliding down into the ocean instead of staying on the land. That will raise sea level in a major way. That's fresh water coming out, where it blew through underneath the ice. These calving events right now are giant. Those pieces of ice are 3,000 feet thick. 1,000 feet above water, 2,000 is below water. But to give you an idea, this is 72 minutes of time exposure. This is Manhattan. That's the size of the buildings in Manhattan. You all are aware of it, okay? Watch this calving. This was 2.5 years ago. The calving phase here, this stuff was not floating in the water. It was on the bottom when it broke off. So this does raise sea level rise. You watch the size of these chunks coming off here. This is over a 72-minute period. I don't need to speak through this. Words, pictures speak for themselves. Wow.
In 72 minutes it went away?
72 minutes.
Whoa. Manhattan.
That's tall, 3,000 feet. They're 3 times the size. So this is the glacier that you just saw. And they've been following this glacier for a long time. So in 100 years, it moved back that far. However, in the past 10 years up now, I don't know where it is now. I'm trying to find, this stopped in 2010. I'm trying to find new information on where this, but I guarantee you, the last ones I saw, it had turned the corner up here, was starting to go back into that glacier. There's another glacier right here going back. That's the main glacier that you were looking at there. Okay? Hello, welcome. Tundra. Tundra is frozen earth. It's frozen down 150, 200, 300 feet or more. All right? It's getting hotter. Permafrost. That's all frozen earth, and it's getting warmer and warmer and warmer at all levels. And it's starting to melt. You can't melt it because it's holding so much carbon dioxide and it's old stuff. From dead plant material that's in it, this is all the old plants that died and rotted and then froze. So it's holding all that carbon dioxide and methane, which is much stronger than carbon dioxide. In the northern latitudes, in every country, they don't put foundations down because the earth is frozen. They put buildings on it. And then when it melts, it falls apart. We put our pipelines elevated so we don't melt the tundra. But when it melts, it just turns into mush. And then all that carbon dioxide that is there, and these holes right here are melt. That's the melt of the permafrost. It makes methane. Watch them light it on fire. They're on one of those holes, poking holes in it. All right? So all that is putting methane. And methane is 23 times more powerful at warming our atmosphere than carbon dioxide is. It only lasts for 25 years. But during that time, it's 23 times more powerful. And there's a lot of it here. And tundra's melting everywhere, all the way around, Siberia, everywhere. This is a gorilla, a 600, 800, 1,000-pound gorilla, watching us in climate change right here. Now, let's go to Antarctica because there's a lot of ice there too. All right, and we're going to look at some of these glaciers, but here's something that you're going to find interesting. Here's calving going on. All of this stuff that was on the land, when it ends up in the water, it actually raises it, okay? I think we're going to look at the Smith Glacier on this one with a cutaway. The amazing thing about Antarctica, it's a continent, right? It's got so much ice sitting on it that it has pushed most of it below sea level. Most of the land in Antarctica is below sea level. Not the big mountains, but this is going to cut away and it's going to show you. Most people are shocked by that. But what happens when you make the water warmer than freezing? Just a little warmer. 33 degrees, salt water freezes at 31 and a half or something like that. All right? Let's take the ice away. All of that brown is lower All right, right now, these glaciers are feeding down to here from the center, okay? But all that you see right here is below sea level. If you start melting these glaciers from the bottom up, all right, and you watch their calving front right here, and you can watch it's being melted from the bottom up, and you can see it go right here. Sooner or later, that seawater is going to get underneath that whole mass of ice on Antarctica and start melting up, but from the middle of the continent. Okay, it's too warm. Scientists said it would never happen, that this would be here for millennia and millennia, that we couldn't make it hot enough to do this, but they didn't say we couldn't make the ocean water hot enough to do it. And we have made the deep ocean water hot enough to do it. You can see it happen right here. Now the way they get this, they take x-rays from an airplane, shooting down so they know where the bottom is. If you've been on a boat, it's like looking at a fathometer. It shows you the whole water column and what's on the bottom, okay, with any fish in between. I don't see any fish in that. This looks fishy, right? Okay. That's pretty scary stuff. Here's something that definitely affects us in South Florida. These are the ocean currents, and the Gulf Stream that you just saw right there moves up right to the North Atlantic. That's Iceland and Greenland. And as the salt water gets colder up there, it gets denser, and it's got salt in it, so it's really heavy, and it sinks. As it sinks, it pulls the rest of the water behind it down with it. Okay, and that keeps the currents running all around the world. Every current in the world, deep water currents or surface currents, are connected. It is a giant river that's connected, all of them. What has happened is that so much ice is melting in Greenland, it runs out and it gets in the ocean just off the tip of Greenland there, and it turns the water fresh, or fresher, let's put it that way. So when the Gulf Stream gets up there, and that current is going to, heavy salt water, right, compress as it gets colder and start to drop and pull the Gulf Stream along, all right, doesn't happen. Too much fresh water in it. It can't attain the weight that it needs. It gets smaller, but it's fresh water now. It's not salt water, and it's not sinking as fast. So the Gulf Stream has slowed down 10 to 15% since they started looking at this about 12 years ago. We have radar that goes across from Miami to the Bahamas and from Palm Beach to West End, and we watch the Gulf Stream move, so we know exactly how fast it's going with this radar. 10 to 15%, what does that do? Think about this, between Miami and Bimini is 48 miles. The Bimini side of the Gulf Stream, as it comes around Florida, centrifugal force is 3 feet higher than the Miami side. So when you're going to Bimini in your boat, you're actually driving uphill 3 feet, okay, across the water. If you slow it down, what happens? It starts to equalize with the other side because it's not going as fast around the corner. So Miami, South Florida, has the highest sea level rise due to water, not due to subsidence, like Louisiana, where they take the oil out, the ground sinks, and they have sea level rise. Due to water, Miami's #1 in the world, 6 times faster than everywhere else because the Gulf Stream's slowing down. Now, if the Gulf Stream's slowing down, and we know that it's connected to every other current around the world, the ramifications for this are huge. We just don't know what they are yet. But give it another 15 or 20 years, we'll have a darn good idea. All right, ocean temperatures is an amazing thing. To raise the ocean, full ocean, which averages 13,000 feet deep, and it's over about 72% of the Earth's surface, takes 300,000 to 500,000 years, naturally, to raise it 1 degree. All right, 300,000 to 500,000. We've gone up 2.2 since 1950. And it's deep ocean. I just showed you Antarctica. That's deep. That's water from the deep coming up. They used to be really, really cold. That water was well below from the pressure. All right, and the fact that it's salty used to be well below freezing. So when it got to the ice, it didn't melt the ice. Now it's not. Now it's 33 degrees, 32 and a half. It melts the ice, fresh water. The ice is fresh water. And salt water melts it. So since 1950, we have raised it 2.2. It's trapped a huge amount of heat. If it wasn't for the ocean sinking in all this heat, we probably wouldn't be talking here today because the atmosphere would be so hot that we wouldn't be here. But it's all getting trapped in the ocean. Now, I said we could take carbon dioxide out of the atmosphere, all right? But we cannot take carbon dioxide out of the ocean. And I'll get to that in a minute. There's no way to do it. We could, in the atmosphere, you could geoengineer yeast, which we seem to use for everything, so that it eats carbon dioxide molecules, and we could fly around and throw that yeast up in the air and let it eat the carbon dioxide molecule and die, because it only lives, what, yeast, bacteria, if you throw it out there 24 hours, all right? Problem is, how do you turn it off? You don't want to eat all the carbon dioxide, right? But, you know, we could engineer this, all right? But if, knowing how long it takes, we're going to be, to get this temperature out of there naturally, it's going to be 1 million years, 2 million years. And the Earth cannot work if the water gets too hot. It just won't work. And we got no place to put more carbon dioxide. Now this is really interesting. Here's the Gulf of Alaska, United States, California, all right, the Bering Sea. All that red is really hot water. And what happened was, we have changed, when you heat the atmosphere up, it changes the way winds blow. All right? When you change the currents, it changes the way the winds blow. We've always had a wind blowing hard off the coast of California towards Hawaii, and what that did is when the wind went across the surface, it pulled up cold water behind it. So that kept all this area in here nice and cool, and the salmon like that, pteropods like that, krill like that, whales like that, you know, all the things that live up in the cold northwest, you know, in Alaska, they all like that. But now, this was 2014, all right, I already told you about this, and the water sea surface 10 degrees Fahrenheit above what it was. Now that is huge for an area this big, all right? And it's also caused algae blooms here. Now, I don't know if you follow this at all, but Washington and Oregon and Northern California have a razor clam season. Razor clams are on the beach, but they are also filtered feeders. They were closed for the past 2-3 years. You can't go get them and eat them. They're really good to eat. All their Dungeness crabs, couldn't eat them. This is poison. People can't go into water that has this algae growing in it. It's like a red tide. It hurts your lungs. So it's hurting seals, et cetera, all kinds of stuff. But here are the unexpected die-offs that came with this, because it got hotter. It has not gone away, by the way, guys. It's hotter now than it was in 2014. All right? What they've seen die a lot of: sea otters, the seals, fur seals, fin whales, humpback whales, and we're guessing around 300,000 to 400,000 seabirds that are starving to death because with the hot water and with these algae blooms, there's no krill, there's no pteropods, none of the stuff that they eat. Anchovies and sardines have basically gone away because they're affected by these poisons as well. You know, clams and crabs, no Dungeness crab fishery. And on top of it, this whole area, from here up to about there, they have closed down the recreational and commercial salmon fishery this year because the salmon didn't come back. Now, you know, salmon takes 4 years, unless you're a pink salmon, it only takes 2. But Pacific salmon takes 4 years to grow up, a little fish that go down the river, from the stream to the river, out into the North Pacific. They swim around and eat for 3.5 years or 4 years, turn around and come back to the same river that they were spawned in. So if you don't have live fish coming back, you have no salmon. And you won't have any salmon. There are no more that are going to come back and be born in that river and go out and come back. This is pretty severe. And to close fisheries, absolutely just close them right down, cost billions of dollars recreationally, tourist-wise, commercially. All the lodges up here, fly-out guides, commercial boats, packing houses, all right? This is unheard of. It's unprecedented, and they don't know. The article that I read yesterday, an update on this from NOAA, they don't know if they can open it next year either. But they're not looking. They said they're predicting a very low fish count coming back in because they know how many fish are going out. all right? And even if we were to use mariculture and hatcheries and make baby salmon and let them go from these different spots, if they go out to the North Pacific and none of the things that they eat are there, like the krill, that's why their meat is red and pink. Pteropods, same thing, little shell flying thing like this. It's like a little nautilus shell, it's about that big. It's really cute and neat. It's #1 food, that krill. For the whales and everything up there. Well, the whales are dying because they're starving as well. And the seals are dying because they're getting poisoned. And the otters are dying, they're getting poisoned by all this algae blooms. Here's one you never heard of before, okay? This dark water here and the red water is how much dissolved oxygen is in those waters. This is Central America, Africa, obviously, Central America all the way up to Baja California and down the west coast of South America. Where it's really dark, pelagic fish, fish that need to swim to breathe all the time, like marlin, mahi-mahi, tunas, scombers, which are mackerels, things of that nature. Okay, they need to always swim to be able to breathe. They can only go down about 100 or 120 feet. Because below that, there's not enough oxygen in the water for them to be able to live down there. Now, things like squid, snappers and groupers, stuff like that, they can live down there. But a vast majority of open ocean pelagic fish can't. All right, here it's about 220 feet. Here it's about 120. This, when they found in 2010, all right, now it reaches below the hump in Brazil and goes all the way to Venezuela. And there's another one that's big in the Indian Ocean. So this is worldwide. And the problem with this is that it's getting shallower and shallower. I go fish in Central America all the time, Costa Rica and Guatemala. I catch 400 and 500, 600-pound marlin, which I release, all right, on 30-pound tackle. And the reason I can do that is normally if I was in the Atlantic over here in the Virgin Islands and I hook a marlin, it goes down 600, 800 feet, and you can't get it up. It just stays down there. It doesn't want to come up. But the marlin I'm hooking here, they can only go down 100 feet. And it freaks them out. I still got them on the line. They keep coming up and jumping. Well, if they're up and jumping on the surface, I'm going to drive up to them with the boat, grab the leader, bring them up, take a picture, let them go. All right? It makes it possible to do that. And I love it. But I don't love the environmental effect of this. And the reason it's happened is that winds, again, have changed the way currents move. Think about this. On a rough day, like the roaring 40s down here, where it's, you know, even here, you see whitecaps. What are the whitecaps doing? They're aerating the water. All right? It's a giant aerator. So when you have all these trade winds blowing all the time, and you have whitecaps all over the place, it puts air in the water. All right? If it blows hard enough, it pulls up cold, nutrient-laden water. It's not doing that anymore either. We're not getting a turnover of oxygen like we're supposed to, because the trade winds have changed. And you see how the trade winds have affected many different things that I've just shown you about. Okay? This is the bottom of the food chain in the ocean for all fish. All fish. These zooplankton are little crabs and shrimp type animals. They're very small. When you look at them in a bucket after they've been caught with a net, you can't even see them through the mesh. It looks like mist in there. All right? When you put them under a microscope, they look like this. They make up 40% of all the plankton in the ocean, and they are the #1 thing that fish hatch out of eggs. So you've eaten caviar before. Salmon egg is big compared to other eggs that are really small. Okay, if you look at mahi eggs or something like that, they're really small. But a fish hatches out of that little egg, and the first thing that it eats are these. Now, a little teeny fish that just hatched out of a little teeny egg, he can't go swimming around looking for them. There's got to be a lot of zooplankton that basically bump into his face and he can go, I'm eating you. Okay, thank you very much. And as they get bigger, then they can start to swim and hunt. But they don't start by hunting, so there's got to be a lot of zooplankton. Now, again, without the zooplankton, I don't have to worry about killing all the big fish, and then we won't have any little fish left, you know, the big spawners. Because if you can't grow the little fish out from their egg, they're going to starve to death. It doesn't make any difference. Fisheries management makes no difference if there is no food for the babies. Bottom line. Not a fun thought. 40% of all plankton, 60% of the rest of the plankton are one-celled animals. They're called phytoplankton, and they do what plants do, photosynthesis. So they bring in a carbon atom, they hold the carbon in their body, they split off the 2 oxygen atoms and put it back out into the ocean, which eventually gets into the air and into the ocean, okay? And the amazing thing the phytoplankton do, we all know that we get our oxygen from trees. I showed you that very first slide, the earth breathing. Well, it was breathing in the ocean too. I don't know if you noticed all the green going, okay? In the ocean, that's these guys, that's phytoplankton. The reality of the situation is that phytoplankton makes 3 out of 4 breaths that we take of oxygen. 3 out of 4 come from phytoplankton. So if we lose phytoplankton and we're making more carbon dioxide, how are we going to live? We're not going to have enough oxygen balanced to carbon dioxide for mammals to live. Reptiles shouldn't have a problem with it. All right? Dinosaurs didn't seem to have a problem with it. Mammals do. We didn't start to get a lot of mammals until the atmosphere really started to change. All right? Just after the dinosaurs got wiped out by that comet. All right? But the atmosphere started to change, and we started to end up getting small mammals, bigger mammals. Right, because there's more and more oxygen available. We're going back in the opposite direction right now, all right, because of this. Ocean acidification. The oceans are normally acidic. They take in carbon dioxide. The more carbon dioxide that they take in, the more acidic they get. The way it has cleansed itself, normally, it's a carbon cycle, is that those phytoplankton that I told you about just now, they do photosynthesis and they take that carbon dioxide that the ocean's sucking in and they use it. They hold the carbon atom in their body and put the 2 oxygen atoms back up. It's called a carbon cycle. It's a normal thing to do. It was normal except that we're losing our phytoplankton and we're putting a huge amount of CO2 in the ocean. More than all the phytoplankton can possibly eat, even when you have less of it. Okay? So the high levels of CO2 react, increases the acidity, and acid makes this carbonic acid. And the problem with carbonic acid is it eats the shells off of shrimp, crabs, krill, oysters, clams, corals, and zooplanktons, and pteropods, like I was talking about, up in the North Pacific. All right, and it eats them up. Carbonic acid, we all know what it is. If you pop open a can of soda, the gas here come out of CO2, you take the first hit of it, burns the back of your throat, that's carbonic acid. We're old enough to know if you pour Coca-Cola on your battery terminals that are all corroded, what does it do? It eats the corrosion right off of it, right? Well, you could have used that Sprite to do that too. Okay, this is the problem with ocean acidification. Scientists, now this is not me, I'm a boat captain, all right? I'm not a scientist, I'm a boat captain, but I can read and I can build slideshows, all right? And I can put all this stuff together. You don't have to be a rocket scientist to put it together, okay? What are they saying? That the food chain is dying out, and the consequences, that could be, if the food chain dies out, it will be catastrophic. And this is a good one. Human-caused global warming caused a 40% decline in phytoplankton, 40% decline in the plankton that makes most of our oxygen. All right, due to, since 1950, I showed you that other slide, since 1950 we've gone up 2.2 degrees in the water temperature, okay, since 1950. Not sea surface temperatures anymore, this was done in 2010. It's full depth, full depth. The deep ocean is heated up to in a major way. All right, but in 2010 they didn't know that. Science is moving so fast now. All right, they got such a good base to work on, baselines and all that. We're really able to step it up, which we need to. We need to know what's coming as fast as possible if we're going to have any chance of getting out of this alive. I told you about the thinner ice. Here's thinner ice. And the problem that you see right now is that we're getting algae blooms underneath the ice in the Arctic, okay? Sunlight goes through this meltwater right there, and the ice is only this thick. It acts as a magnifying glass, and it puts a lot of sun underneath the ice and heats the water up underneath the ice. So they had a, and it makes, they like that sunlight up there. I don't know, things seem to grow an amazing way in the Arctic, in the colder water. This is a cruise that ship took, all right? And if you look at it from the side, underwater, where you see it dark red, are blobs of algae there, okay? And that was a 100-mile cruise that they took. That's normally what it looked like in the bloom. Well, it looks like our red tides. Just really messy water, but it's all alive, diatoms. And we have the same thing with diatoms here in Biscayne Bay. There we go. And they're blooming out. This is actually frozen methane on the bottom. It's not a diatom. These are the diatoms growing right now. I just want to put that other slide in to show you that methane can freeze too, and that's another issue. Because when you heat it up, it turns into gas again and goes back to the atmosphere. All right, but you can see all the algae growing down there, and it's changed the whole environment. Things that didn't live there are living there now. Look at how many starfish there are. All right, now one of the things about, and jellyfish too, lots of them. One of the things about that hot water blob that I was telling you about up there is that it's killed the starfish all over. That, you wouldn't think starfish would care that much about, but it's killed the prawns there too. North Pacific prawns, great shrimp like that, wiped out. All right, those may grow back if we can get the water temperature down again. Red tides that we have here, these things are poison. Okay, these dinoflagellates are poison. You get them dead in the water, and they give off a gas that'll rip your lungs right out. Okay, really bad stuff, and it likes to grow. It likes hot water, and we got hot water right now. But it also needs nutrients in that water to grow. It's a plant. All right, so if you don't put something in there, some kind of fertilizer in there, phosphates, nitrates, something like that, it won't grow. Well, we got around Florida right now. Come on, where are you? There we go. Now, here's a map I put together. Here's Miami over here on the west coast, Lake Okeechobee. If you look at Lake Okeechobee in there, you can see that the lake is green. That is a brand new satellite picture from a month and a half ago that I stuck in there yesterday. Okay, and that is algae bloom in the lake. Now, how does that algae bloom get there? We all know what's around the lake. We have row farms, we have a lot, 350,000 acres of sugarcane, plus all the other farms. They use phosphates and nitrates to fertilize those crops. And when it rains, like it's been doing, they back pump into Lake Okeechobee to keep their fields dry. Because if the fields are wet, all the stuff dies. So they're back pumping all these nutrients into the lake, and they have been doing it for the 80 years since we drained the Everglades. This was all Everglades right here. Okay, north of it, inside of it, and up there was all regular Everglades. All right, so they've been doing it over and over, and when the lake gets too high, there's a dike around it. Right now it's at 16.4 feet, which is right at, they won't let it go. The Army Corps of Engineers won't let it go higher. All right, they're probably dumping right now, I would think, as fast as they can, dumping water out of the lake. I'll show you that in a minute. All right, so when the lake gets too high, the Herbert Hoover dike runs around it. That was built after the 1935 hurricane, killed about 3,000 people in Palm Beach County when the water got pushed out of the lake and onto all these farm workers there in Belgrade and places like that. All right, so we built it, but it's falling down. All right, so we're going around and rebuilding it, but we haven't done the whole thing yet, so the Corps has to keep the water 16 feet or less. If it was rebuilt, we could probably get away with 18 or 19 feet there, and it would hold it, but they can't now. They like to keep it somewhere around 12 feet. But they're at 16 and a half. Come on in, you can come in. I got more to go. All right, so what happens when it gets really high, they got to get rid of the water, so they go out to St. Lucie, and they go out to Caloosahatchee River. All right, so this is Fort Myers, and this is St. Lucie up there. All right, and they pump a lot, trillions of gallons. So what you're seeing here is a bloom from 2004-05. Well, you remember we had those 5 hurricanes run across the state? I think it was 2004 or 5, something. All right, and so they had to dump the lake out, and it was nice and hot. It happened in the summertime, so we got this huge bloom. This bloom not only killed porpoises, fish, and you couldn't get, this is the Keys down here, so, this black water is the 3.4 trillion cubic yards, that's a lot, of water that came out through the Caloosahatchee, and that's what they call it, a black water event. All right, so that's the dirty water from the lake, and they kept pumping and pumping and pumping. All right, and it killed 208 porpoises, not porpoises, but manatees as well, which is, they're very susceptible. They can't get out of the water. They can't breathe. It's really bad. So what we got going on this last one, we started dumping. This is St. Lucie. These are multi-billion-dollar houses, and those are algae blooms there. Okay? And that doesn't look too bad. All right? But this is the Indian River Lagoon. And just to show you that bloom I was talking about on Lake Okeechobee, okay? Blow it up a little bit for you. That's the Indian River Lagoon, and that's what the lagoon looked like normally from the satellite. Nice and clear. It had an amazing fishery. It's a unique estuary in the world. And because all around the lagoon there is no sewer system, everyone's on septic tanks. Over the past years and years and years, with sea level rise, now the septic tanks don't work right. You have to have a couple of feet of dry earth below the bottom of your septic tank field for it to go down to the ground and get filtered when it comes out of the tank. But now sea level has pushed the water right up to the bottom of the tank, so they don't work. So where do all the nutrients go? These are man-made nutrients. Now, same thing, fertilizer. You take poop, it makes fertilizer. You put it on crops, they grow. Well, there's the algae bloom. That's the crop that got put on. And they've lost 3/4 of their grass flats, huge amount of fisheries. Just an amazing thing. And to give you an idea, this stuff is poison to people and animals, okay? Here's Lake Okeechobee that I was just showing you. Here is the count. Oh, I'm in the way here. This is the toxic algae. If the concentrations are above 10 micrograms, we're not talking a lot here, it's dangerous to people, okay? So, 24, 382, 288, now that's the lake, okay? Then coming out the other side, 27, got 10. But we can get over here, okay? This is St. Lucie, where it's coming out, and where you saw that algae bloom there, but when you see this, and that, and this, and this, and people are living all around every one of these estuaries. Can't go in the water. You can't, if the wind's blowing in the wrong direction, you can't go outside of your house. All right, and all the animals that live here are getting impacted by it. That's what it looked like. It's thick stuff. That's what, everywhere up there. It was thick, it's this thick. It's amazing. What's going to happen to that duck? Now it's trying to breathe there, okay? Few fish died. There's your duck with the green bill. This to me is amazing. That manatee that used to live on the land millions of years ago is trying to get out. It can't stay there. This stuff is killing its lungs. It's trying to get out of the water. That's insanity. When I saw that, I just, that picture says it all. All right, this says it all. These all died from that bloom up there, and it was one of 400 manatees that died. These. They didn't die from boat scars, those are old. They all died from that bloom, and it's going on right now because the Corps of Engineers had to release more water, poison water, from Lake Okeechobee, and as an environmental attorney, I know that you know that the sugarcane growers will tell you to this day they have cleaned their mess up. And they don't need to be regulated anymore. And they're not going to give us back any of the land that was state land leased to them so that we can build marshes that will clean the mess out that they put into Lake Okeechobee rather than send that nasty water out the Caloosahatchee River and mess the west coast up, or out St. Lucie and mess the east coast up. And they're fighting it tooth and nail. But if you take the governor of Florida on hunting trips to your ranch that you own as a sugar grower in Texas, on junkets along with other legislators, they tend to want to not finish out the Everglades project the way it was intended to be, and want to let you keep doing the same poisoning of the environment that they've been doing now for 80 years. And it pisses me off. I'm not the only one. That picture pisses me off too. Coral bleaching. We basically have no more coral left. This is interesting, okay? Coral has a symbiotic relationship with an algae called zooxanthellae. Zooxanthellae lives inside the coral. It gives the coral its color, but the coral also eats it. The zooxanthellae make a sugar in their body through photosynthesis that the corals like and eat it, and they get protein from it, okay? The zooxanthellae also gives the coral that carbon atom it needs to be able to make its shell. When it gets too hot, the water gets too hot, the zooxanthellae start producing a poison rather than the sugar, and the coral kicks them out, and and they don't have color anymore. They're still alive, but it kicks them out, and that's why they call it bleaching, because the corals turn white. If we can get colder water up there again, the zooxanthellae will come back making sugar again, the corals turn regular. But if not, after a couple of months, bad algae starts growing all over them, and then a storm comes along, and wham bam, it's gone. And you saw Keith, the other professor, said when he was up on his mini vacation after the storm in Vero, I think it was, or Boca or something like that, he was at the beach with his family, and it was littered with dead coral. Okay? We have very little coral left in South Florida at all, and the Keys is dying as well. All right? I sit on the Southeast Florida Coral Reef Initiative. I'm a vice chair of that, and I keep telling them, guys, you can make all the marine protected areas that you want and stop everyone from going around where there's supposed to be reefs, but if we don't get a handle on ocean acidification, ocean temperature, we're not going to get any corals back. This is Carey's Fort Light. This is the northern Keys. All right, you see coral reef all around it. I've fished here since I'm probably 12 or 13 years old. All right, that's what the reef looked like. I used to snorkel this. There were huge fish all over it. And I mean, this is 1975. I was 25 years old then. All right, here it is in 1985, 10 years later. It's already bleached, but you still have relief. You see, it still goes up and down. There's holes and crannies and all that. So it's still a viable environmental area for fish. Okay, although when you start looking at it in 2004, it's starting to collapse even more. 2014 even more, and today, all right, but this is due to ocean acidification. The corals that are there and alive cannot take calcium carbonate out of the water to build their shells fast enough to overcome the acidification in the ocean that's eating it. Now, acidification does another thing too. It stops the corals from being able to get calcium carbonate out of the water. Right? So it's hitting them with a double whammy. It's bad stuff. And then this stuff gets eaten. The coral just keeps getting eaten and eaten and eaten. Okay? Until it turns into sand. Basically is what it is. All right. This is going on South Dade and Northern Keys in a major way. And now it's starting to spread north and south. All right. There's still some places in the Keys that are fairly healthy down around Dry Tortugas. They're lucky they get very cold water coming out of the Gulf of Mexico deep. They're sticking out in the middle of the Florida current when it comes around Florida, and it's washing them and bathing them all the time with good, healthy, cool, nutrient-rich water. All right, but most of South Florida is not like that. Mangroves, we know. Without mangroves, we would have got, with this storm that came through here, even though it was on the west coast, it would have pushed waves right across onto us, and we would have got a storm surge from the west, and it would have been devastating. All right, so mangroves protect us. It also is a nursery for all kinds of juvenile fish, shrimp, crabs, stuff like that. But they're under stress all around the world because people are chopping them down to do mariculture. They want to grow shrimp there or fish. Cities want to expand all around the world, so they waterfront property, cut them down and fill them. Like Miami Beach was all mangroves. They cut it down and filled it. Problem with mangroves, and why they're going to really be stressed and they're not going to be around, and you can't go plant them, is that we're expecting 3 to 6 feet of sea level rise by 2100, and a mangrove, that little shoot right there, can't take more than about 9 inches a century because its roots are covered in a bark that won't let the salt water in. But if it gets up on the green part of the stem, the salt water will intrude into the plant and will eventually kill it. All right, but we're shooting for this. Okay. So now I'm getting to the crux of it. This is where, as attorneys, you guys, if you're going to be environmental attorneys, or land use attorneys, real estate attorneys, all right, are really going to have your hands full coming soon. Okay? Ice melt and rising ocean temperatures, what does it mean? I don't think you want to see this, but here goes anyway. Okay? This is South Florida. This is the Everglades. This is an urban development boundary. Northern Key Largo, Elliott Key, Turkey Point Nuclear Power Plant. This is Homestead. Tracks over here, air base there, Homestead, Florida City. Looking up here, Key Biscayne, Miami Beach. All right, we're up somewhere around in there. All right, That's what it looks like right now. If you look at this side by color, you can see the elevation. All right, so when it's dark green like this, it's 0 to 1 foot. And here's what 1 foot of sea level rise would do to South Florida. Now, this is all of our row crops down here, Florida City and Homestead. That's tomatoes, beans, okra, all that corn, you know, all the winter crops that we get, strawberries and all that, that's that. But this stuff right here is Cutler Bay and Pinecrest. And those houses on the bay are worth between $8 and $30 million. I don't care how rich I was, I don't think that's a good investment. Okay. You know, what can I tell you? But that's with 1 foot, all right? We know 1 foot's coming in the next 12 or 15 years. And we're already at a foot from where we were in 1935. We've already gone up a foot. This didn't reflect it. This took it right from where it was, okay? Now, Turkey Point, which I find very interesting, is now an island. They want to build 2 new reactors, okay? I sued them on that. I'm one of 2 people who's standing on that lawsuit against the NRC, Nuclear Regulatory Commission. And one of my contentions was, don't build it here, build it somewhere else, build it where it's not going to be in jeopardy by sea level rise in South Florida, because you only have an elevation of 6 inches. All right, and the NRC said, that is not a valid reason when we go to cite this plan. And I was like, you got to be kidding me. Anyway, we're still in court with it. All right, here's 2 feet. You're really starting to go way up here. Miami Beach, where I live, right in here, see that is going underwater. 2 feet. The Mayor Levine says, you know, we're going to engineer our way out of it on Miami Beach. Ain't going to happen. You can pump and pump and pump, but you're not pumping all the ocean out of it. You can build walls as high as you want, but we live in South Florida, man. It's sand and limestone. You build a wall, water goes underneath it, percolates right up behind it. So I don't know how that's going to work. This is the airport now. It's underwater. Here's Doral. You guys are starting to get it up in here. All right, here's Doral, the new city they're building in Doral. All right, starting to go. But, you know, this is only with 2 feet. This is only 2 feet. 2 feet could easily be 2040, 2045. Here's 3 feet. Now, Miami Beach is gone. We will have had a hurricane come through and run right over us. Surge, take it right out, because it's all sand. So this will be the new coastline. But here's another problem coming up. Regardless of Doral being gone and Kendall going away, and salt water up into here, that's a Tanami Trail. So this is all salt water back here, no more Everglades, okay? These islands will all be gone. But here's another problem. These are called transverse glades. Those were the way the Everglades used to drain out normally. And when we wanted to drain the Everglades, we built our canals there. All right, but if you notice, they're all turning back into little rivers and creeks again. Okay? Here's 4 feet. Now, NOAA is saying, National Oceanographic and Atmospheric Administration, is saying that we can expect up to 8 feet of sea level rise by 2100. Somewhere between 5 to 8 feet. It keeps going up. They keep changing their numbers, okay? So here's 4 feet, and this is all Miami-Dade County that's left right here. And, you know, you're not, what are you going to build bridges across this stuff? Now, what happens when a hurricane comes here? Because this is all salt water now, you're going to get a surge, because all of South Florida's gone. The whole Everglades is gone. It's water all the way across. So you get a hurricane come up just like this last storm did and hit the west coast. It's throwing 20 feet of water all over what's left of Miami-Dade County. So 4, 5, 6 feet. All right. And then they said, maybe 8. So let's go to 8. That's all the land left. So when I said you guys are going to have your hands full as attorneys, all right, how do you move 3 or 4 million people out of here? Because people are still coming. What happens when your house gets flooded because of sea level rise and the storm comes by and you want to rebuild the same place? How do you take people's houses from them? Because you know it's unsafe, and you need that land to do something else, whether it's the Danish model, okay, where you turn the land back to water and then you move, and floating houses and all this kind of stuff, all right? How do you do that? Well, the laws are going to become very, very involved in this. Zoning laws are going to have to be changed. Property rights laws are going to have to be changed. What do you do with the 3 million people that you just took out of downtown Miami or many immigrants, many poor people, many more poor people than rich people. Rich people, I just sell my house in Miami Beach, make a nice profit and leave. All right, but what does a poor person do? All right, they can't go. This is going to be a big mess. Nobody in government's talking about this at all. I was the chairman of the Economic, Social, and Health Committee of the Miami-Dade County Climate Change Advisory Task Force. We met for almost 5 years. My number one push as chairman of that was to somebody please deal with this issue of what are we going to do with the people that don't have the means to get out of Miami-Dade County or South Florida. Let's start talking about it now because it's going to be a monumental task. All right, and then do you leave all the built structure in the ground? And the pollution that would come from Mount Trashmore, which is still up right here, and the sewer plants like on Virginia Key, which is still up, what do you do? All right, these are good questions, but Dr. Hal Wanless at the University of Miami, he's the head of the geology school, says that we're going to get 12 feet. Well, we know we're going to get 12 feet, whether it's in 2150 or 2110, we're going to get 12 feet or 2200. But that's what South Florida is going to look like. So in reality, guys, we've got no South Florida left. That's the reality of the situation. Sometime in the future, either near or a little farther, there will be no South Florida at all. Now, that's not just us. Every coastal city in the world is going to go through this. Every single one. Are we planning for this? No. Is there any way to stop it? No. Don't you think government should be freaking out about this? Yeah. When you look at Houston, look what happened to the price of gasoline because they flooded there and 15 or 20% of our gas came from the refineries there. Well, imagine, when Houston's going underwater, it's only 3 feet. They can't build walls there either, and all the infrastructure that we have going on there. You think New Orleans was big? We spent $25 billion on New Orleans. South Florida, according to the United Nations and a Tufts University study, stands to lose $3.2 trillion in infrastructure. It's the largest infrastructure loss in the world, dollar-wise, right here in South Florida. $3.2 trillion. Wouldn't you think it's worth some money maybe to at least get the Everglades flowing south again, and put a 6-foot freshwater head on top of this just to hold it back for enough time so we can move everybody out reasonably instead of getting flooded out? Flooded out is not good. So I took these pictures on Miami Beach in 2012. This is 10th Street. That's the Fresh Market there for any of you that are aware of it. This is Alton Road. Now here's what happens to Florida with 2 meters, 3 meters, 4 meters. See, Lake Okeechobee is gone, so it's, and we could easily get 5 or 6 meters of sea level rise within the next couple of 100 years. Florida would look like that. And we've looked like that before. Okay. I'm happy to say that we're not flooding like this on Miami Beach now. The pumps that the mayor put in, gotta give him credit for that, they did work. For here, up to a point. We're going to see, how long. We don't need to see this anymore. I've kept you here for a long time. We're going to move on. This is Florida, as it's been many times over and over. As a matter of fact, it used to be this wide. That shelf out here, Florida was that wide when we had an ice age going and all that salt water got turned into ice and then the oceans lowered. We have the same amount of water on this planet. It's finite. Absolutely finite. It's only in a few places at once. It's either in ice and glaciers, it's in the ocean, it's in lakes, rivers, and streams, it's in the atmosphere as clouds and moisture, or it's in aquifers. And that's it. That's all the water we got. We just keep shuffling it around, moving it around. The Earth does. Pretty cool. So what can you do? I have to end with this. What can you do? I'm telling you guys, don't give up. I'm a pretty depressed guy, all right? But you don't have to be. What I just showed you really is not fun stuff at all. But if it doesn't get you motivated, I don't know what will, okay? Changing laws, much more important than recycling, changing your light bulbs to halogen, or not halogen, from halogens or regular bulbs, incandescent. to the LCDs and all that stuff, okay? Forget that. I mean, great, it makes you feel better, but does it really help the environment? Yeah, I don't mean environment by, I'm talking about the climate when I say environment, okay? You don't change laws, you don't get us back into Paris, you don't make it stick. You don't mandate that car companies go, well, we're going to have flex vehicles that are half electric, half fuel, and it's going to run on hydrogen instead of hydrocarbons, and you know, I mean, we got to mandate this. We have the technology to do it. We have the money to do it. We have the brilliance of people. We don't have the will. We are selfish. We are selfish and self-centered. We don't want to change anything because we live fat and sassy. All right, it's not only the United States, it's a lot of places. Okay? All right, if you don't tell your leaders that it matters to you and that it is the most important thing, will get you out of office. All right, this is number one on the list. Terrorism is not number one on the list. Okay, all these other BS things that go down that list is not number one. This is number one. This can kill us. This will be the sixth extinction. Mankind will die from this. All right, if you have any morality at all, you cannot allow this to happen. And the reason I'm standing here, I'm not a religious guy, okay? I'm Jewish, but I'm not a religious guy. But I feel a moral obligation to take this word out to as many people as I possibly can, and I challenge the young people that I talk to get motivated. You guys can change the world with your thumbs. Social networking, you can change the world. We've seen it happen. I didn't have that opportunity when I was young. You do. You have the technology to change it. And you should be pissed off about this, you should be angry about this, and you should want to do something about it, and you should get your friends to this talk the next time I give it. And fill this room up so that they can be engaged and involved in this as well, because just a few of you will not get it done by yourself. It has to be a full movement. So where do you start? Time to take action is now. It was before. It might be too late. I'm praying it's not too late, okay? Go to 350.org. 350 stands for bringing the carbon dioxide in the atmosphere down to 350 parts per million, rather than 450 or 550, where we're heading to. All right, and then working from there, because if we can get it down and work from there, you will live. Things will be radically different, and Miami won't be here, and South Florida won't, but you will live. All right, and then you start to build again. You start to build a world again, you know, that will be a better world. Because we should have learned by our mistakes by then, I would hope. I would hope, okay? So that's a great organization. There's a local branch, and it's national as well. And this one, Citizens Climate Lobby. These guys go to Washington. They're there all the time. They go to Tallahassee. They go to every state capital. All right. They show up in Washington, 25, 30,000, 40,000 people. They walk the halls of Congress. They're with their senators. Okay. It's a great organization, and we have a very strong chapter right here. All right. And, you know, what do you do now for the next 4 years, or 3 years and 5 months? I can count the days for you too. All right, and hopefully it's not the 8 years that it could be. What do you do? You've got to get in there, guys, and change the system. All right, Trump was right. System stinks. All right, unfortunately, they didn't change it the way it needs to be changed. You need to change that. All right, now, I'm going to end on this. I did a little scientific study. All right. Well, it's not that scientific. Have you ever noticed how people tend to look like the dogs that they own? I think anglers tend to look like the fish they catch. And with that, I will close, and I thank you very, very much for having me here. And I'll take any questions you have too. If you have to go, I understand there's other classes and that sort of thing, but hopefully I will come back and be happy to take questions. And guys, please, 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 please get motivated on this. Each one of you can do this what I just did right here for hundreds of people. And over the course of your life, you can too. So make your decisions wisely. Okay? Thank you.
Thank you.
Any questions? I got a question.
I was going to ask